Okay, so let theta be an angle in standard position. Terminal side passes through point AB. Okay, what this one want to say is okay, this theta is angle in the standard position. This is theta. Okay, the angle is called the argument of the complex number between 0 until 2 pi. So one cycle you can find the angle. Okay, complex number but it's in polar form. Okay, not polar bear. Polar form, remember that cos theta is A over R. Oh, lupa nak cerita R. Okay, sorry, I forgot the R here. See if we have R. Okay, R is an absolute value of R. So remember you find the distance just now. Okay, this one, the highlighted in yellow, this is called R. If you want, just now we calculate as absolute value of Z. Why we put R? R is radius. Let's say this point, it moves from 0 degree to 2 pi, you will have a circle. So R here, they denote as radius lah. So we use R. Or the hypotenuse. You see you have a right angle, so this is B, this is A. So from here they come out with the cos theta concept, sin theta concept, and also tangent theta. Okay, but it's not C, they use R. The concept are the same. So cos theta is A over R. Okay, so we have A over R. So A over R, we want A only. What is A value? So R, we times both sides with R, we have R cos theta. So A equals to R cos theta. Or we just move R here, then we have A equals to R cos theta. Similar to sin theta is B over R. Okay, remember this triangle just now? So we want B only, so it becomes B equals to R sin theta. Now we have you have A equals to R cos theta, B equals to R sin theta. So we know that our standard form is in A plus BI. This is our standard form. So how we want to convert into polar form? How? We have A, remember A? So our A is this. We have B, and our B is this. So put it inside our Z equals to A plus BI. So A is R cos theta, B is R sin theta. I, still I. Okay, next you see that first term we have R, second term also we have R. Okay, the only thing that is similar from first term and second term is the R. So I take out the R. So what's left is, I put bracket cos theta plus I sin theta. Remember, I usually at the back, but in terms of angle, we usually put in front of the trigonometry so that you won't get confused whether I should be behind theta or behind the sine. Just put in front of the sine. Okay, so this is the form of in the polar form of complex number. Okay, this is in standard form, this is in polar form. Okay, why polar form? If you have the angle, so you put in the polar form. Okay, next we want to learn how to convert from standard form here to polar form. Standard to polar. Later we reverse polar to standard. Okay, so complex number in polar form. So see, you have in standard form. How you want to change into polar form? Okay. I need to write. Okay, so we have Z equals to 1 plus I. Okay, number 1. So what is our A? A is 1. What is our B? B is also 1. Not 0. Remember when you write X, how many X? It is 1 X. Right? When you have A, How many A? 1A. Usually 1, we don't write the 1 in front. So when you have I, 1I. Okay, so B is 1. Don't say 0. If 0, then I is no longer exists here. So how to write in a complex, you want to write in a polar form. Plotting you can do, right? Just now I teach you already how to plot. So now I just want to teach how to write in polar form. So polar form, and then what we need, okay, I think I need to write Z equals to R cos theta plus I sin theta. What value that we need? Obviously we need R. So how to find R? R is A squared plus B squared, square root. So I will have square root 1 plus 1 is 2, 2 set 2. This is my R. Okay. Next we want to find the theta, the angle here. So how to find the angle? Choose sine or cos. Cos or sine. Okay, or you want tangent also can. Okay, up to you which one that you prefer. Oh, sorry. Okay, sorry. Okay, next. Let's say I use cos. Cos theta is A over R. Okay, I have A value. So cos theta is A is 1. What is R? R is square root 2. So cos theta is 1 over sec 2. What is theta? Inverse cos 1 over sec 2. So what do you get? Take your calculator, press shift, cos, we will get inverse cos 1 over sec 2. Apa ni? Okay, so I get 135 degree. Now we have the angle. So once you get, see the theta here is the same as theta. Symbol same, meaning they share the same angle. So therefore your Z is equals to R sec 2 cos 135 degree plus not enough space, I sin 135 degree, like that. Done. Okay, so not necessarily means that if you use cos you can only put theta here. No, the theta will be the same for both because they share the same symbol. If I don't want it to be the same, then these two will not be the same. Okay, let's say you don't like cos, you want to use sine, also can. Alright, use sine, you will get the angle. It's supposed to be the same angle. Remember when you plot, when you plot, this is imaginary axis, this is real axis. So plotting is A positive, B positive, so it's here. So you will share the same angle. So 135, so same angle. Itu ke 135? Ya Allah, salah ni. Sorry guys, it's not 135. Mabuk pagi-pagi. It's not 135, right? It's at the first quadrant. It's supposed to be less than 90. Ayo, sorry, wrong pressing calculator. 45 degree. It's 45 degree, guys. Okay, so here is where's my pen? Tak keluar. Okay, this is 45 degree. So this is number 1, which is plotting at A1, B also 1. You plot nicely. Z 1 plus I. Okay, so in polar form you will get sec 2 cos 45 plus I sin 45. Okay, sorry, accidentally I put a negative, that's why my answer is wrong. Okay, so usually it's very good when you need to plot. Just now I didn't plot, so I'm so confident that my answer is correct, but when I plot, I look at my angle, it seems so weird because we should have a positive and it's supposed to be an acute angle which is less than 90, more than 0, so it's supposed to be 45. So I recalculate because I accidentally pressed the wrong value. Okay, it's good for you to have the plotting so that you can check whether your angle is correct or not. Okay, just for your information, like I said just now, you can use cos, sine, tangent, whatever trigonometry that you prefer. But if you calculate and you get the angle negative, again see your plotting. Okay, it's either the calculator gives the reference angle or the angle turn clockwise. It's supposed to turn anti-clockwise, right? But if your angle turns clockwise, meaning you will get the angle is negative. So don't panic, check first. Okay, you have learned how the angle becomes negative and so forth from Maths 1, so refer back to your